Dermot McAteer, thank you very much for volunteering tonight, even if Simon Irwin did volunteer you on your behalf. I'm going to hand it over to you. Folks, as I mentioned at the start there, there'll be a Q&A section at the end. If you've got questions that come up during this, stick them in the chat. We can either tackle them through the talk or at the end, and we'll kind of act as a mental note for what people would like to talk about. Other than that, thank you very much, Dermot, and over to you.
Dead on. Just entitled this talk as Shifting Terraform Automation Left with Atlantis and DivvyCloud. So without further ado, I'll jump into it. So the agenda tonight, I'm going to give you a bit of an introduction about myself, kind of go through the problem that Rapid7 were having. We're going to look at the tooling. So what is Atlantis? What is DivvyCloud? We're going to look at the architecture of how we deploy these two services and the kind of installation steps required to get them up and running. Going to go through the workflows. So we'll look at the typical Git workflow that most of us are familiar with. Then we'll look at how the Atlantis workflow differs from that typical Git workflow. And we'll look into what is shifting left and how the DivvyCloud infrastructure as code scans enable that. Then a bit of a live demo and talk about where this project is going to probably end up going internally. And then we'll just finish it up, wrap it up with some questions and answers. So a bit about myself. I'm a software engineer on the platform delivery team. Been at Rapid7 just over a year now and been working in DevOps for the last 2 years. Pretty varied job working on the PD team within Rapid7, touching a lot of different tools and frameworks such as AWS, Terraform, Kubernetes, Jenkins, Python, even a bit of Node web development as well. So the problem that Rapid7 have been having is there's a lot of Terraform repos. There's 133 repos in our Rapid7 GitHub org. And we're running over 7 production regions, 2 staging regions. And as a result, all the Terraform init, select the workspace, the plan and the applies all start to add up. A lot of the time engineers are running Terraform commands locally on their machines. And whenever they are running these Terraform commands locally on their machines, a lot of the time they're running targeted plan applies and destroys, or even more still, they make their changes through the AWS console, completely bypassing the Terraform state. So a lot of engineers find that infrastructure is a bit of an afterthought. So Terraform is just like another tool and language they have to learn. And they have issues with Terraform versions, third-party binary installations, and even just the Terraform syntax in general. And all these problems kind of result in infrastructure ending up out of date, known as configuration drift. With the amount of workspaces and regions that we're dealing with, you're getting human mistakes are just going to be made. So we see things like engineers deploying into the wrong workspace, using the wrong Terraform variables file with the wrong workspace, introducing maybe security vulnerabilities or resources that are not making compliance with the Rapid7 policy, and then InfoSec jump on the case. And realistically, there's no real audit trail of any infrastructure changes, and we can't find out easily who made the change and when that change was introduced. So just a quick overview of DivvyCloud. So DivvyCloud provide a security platform to monitor and remediate problems in your cloud infrastructure. And Rapid7 acquired them in April of last year. So we've been kind of working on integrating the DivvyCloud services into our workflows and giving some feedback to the DivvyCloud team and to help improve their tooling. And the DivvyCloud platform provides this tool called the Infrastructure as Code Scan tool, and it provides us an endpoint that you can post your Terraform plan file to. So DivvyCloud run checks against your plan file and returns a report outlining what scans have passed or failed. So DivvyCloud are looking for things such as like port 22 completely open to the internet, or S3 buckets with public access. So all these checks are based off these DivvyCloud insight packs, and insight packs are just custom rule sets for looking for misconfigurations or defects within your infrastructure as code. And this scanning process is an approach that's known as shifting left. And shifting left is just the practice of finding and preventing defects earlier in the delivery process. So just find the issues before they're deployed and require remediation. Then jumping on to Atlantis. So Atlantis is a purpose-built tool for automating Terraform plan and applies using version control pull requests. It's a completely open source tool written in Go, and Atlantis works out what's been modified in your PRs using like a git diff, and it only plan and applies the what's changed. So you can control Terraform straight from the PR by simply commenting with an Atlantis keyword in the PR comment. And then you can also set conditions. So you can make sure that before you get Atlantis to run a Terraform apply, the code that's in the PR has to be mergeable. So no merge conflicts with like the master branch, and you have to have somebody that's approved the PR as well. So it adds in a bit of a block if those two conditions haven't been met. So the typical Git workflow that we're all kind of accustomed to, you get like an engineer creates a feature branch, pushes that change and opens a PR. And then that PR gets code reviewed. And once it's all been approved, the branch is merged into master. And then normally, if this was a Terraform repository, the engineer would run the Terraform commands locally to apply those changes. So how does that differ from the Atlantis workflow? So a developer creates a feature branch and pushes their changes, and then they open a PR as they normally would. But whenever they open a PR, there's a webhook that's triggered, and Atlantis receives that PR information and clones down the PR branch. And then Atlantis runs a Terraform init, a workspace, and a plan, and comments that plan output back to the pull request. And once that pull request gets code reviewed and the plan output was successful and it's ready to be deployed and it's been approved, the developer or the engineer who submitted that PR, or anyone for that matter, can comment Atlantis apply on the PR, and then Atlantis completes a Terraform apply and posts the apply output back to the PR, and then you can merge in your change into master and delete that branch. So what does it all kind of, what parts make up this this workflow? So it consists of an Atlantis Fargate Terraform module, and you can find that. There'll be a wee bit more information on this in the next slide. You also have to create a GitHub webhook and a user. And then we've got our DivvyCloud endpoint here, which is just like a HTTP API endpoint that we can post our plan output files to. So the Atlantis Terraform module, it can be found on GitHub. It's got quite a good community. It's nearly got as big a community as Atlantis itself. This module provides the compute resources for Atlantis to basically run. So it's running on AWS Fargate, which is like a Lambda, but it runs a container instead of running code. That's how I kind of try and think of it. The module also adds some like supporting infrastructure. So it'll add a VPC if you haven't specified VPC and subnet IDs. It will then create you a load balancer for the GitHub webhook to hit. We've actually locked this down, this load balancer down to our corporate IPs, and the GitHub webhook IPs as well to allow traffic to hit that from GitHub. It also creates you the Fargate service container, an SSL cert for securing that load balancer, and a Route 53 domain record as well. Then you need to add your GitHub user, and all it needs, you just add that user to the GitHub repository and give it read permissions. It doesn't really need any elevated permissions other than that. And then you create your webhook. So whenever you create or run your Terraform apply of that Terraform Atlantis module, it'll output you all of these like details, such as your payload URL and your webhook secret. And then you just enable the following events. So you allow that webhook to issue comments, pull request reviews, pull requests and pushes. And then the DivvyCloud endpoint. So our DivvyCloud installation is hosted on premises, and the infrastructure as code scans are reachable through an API call, like I was saying earlier. You could alternatively completely swap out the DivvyCloud scans and put another static infrastructure as code scanner in place, like Checkoff or TFSec or Kix. And then you could run these alongside the Atlantis container, which is running on Fargate, or you could create another external service, like another Fargate container or a Lambda function to run those scans if you want. So now we're going to kind of jump into, well, how does it all get stitched together? So you make use of this configuration file called an Atlantis.yaml. The Atlantis YAML file, it's not necessarily required to get Atlantis up and running, as Atlantis will use its own default configuration, but you will require the Atlantis configuration if you're planning on doing anything more than just Terraform init, plan and apply. So if you're thinking of using a Terraform variables file, like a TFRs file, you're going to need one. If you're looking to support multiple workspaces, you're going to need this file. And then if you're looking to run any custom commands as part of the plan and apply phases, then you're going to need an Atlantis YAML. So you need this file basically to overwrite the default Atlantis configuration. And you basically just place that inside your root repository. And then you can see that the file is actually split into these two sections. So you've got your project definitions and your workflows. So a project definition consists of a name and an ID for the project definition. So it's just an ID to pretty much uniquely identify this project block. You've got the directory. So this is the directory to run your Terraform commands. Then your workflow. So this is the Atlantis workflow that it's going to run for this project definition. Be more on that workflow in the next slide. We've also got the Terraform workspace that you're going to run the plan and apply against. You've got your apply requirements. So these are the criteria that must be met before the Terraform apply can even be triggered. So we actually have it set so that you have to have the PR approved, and it mustn't be conflicting with the master branch. And then we've also got the auto plan enabled. So as soon as that PR gets submitted, it automatically runs your Terraform plan init and your plan. Just a quick note on this Atlantis YAML, the settings, they can be configured on the server side as well, just to prevent anyone bypassing settings like your apply requirements. So on to the next one, which is your workflow section. So workflows describe the Terraform plan and apply processes, and each workflow can be broken into two sections, the plan phase and the apply phase. Plan phase runs your Terraform init, your workspace, and your plan, and it's got a couple of extra arguments in here. So yeah, your extra arguments are used for supplying extra arguments to the Terraform plan command. We've actually nested a wee bit of bash in there. that runs a Terraform workspace show command. So by running that command inside that workflow, it just prevents us having to maintain and write individual workflows for every single project definition. So whenever that Terraform workspace show command runs, it will just print us out our var file because we've got our workspaces and our var files named exactly the same. Sorry, jumped the slide there. And then this here's your apply phase, and we're not doing anything special in there. We're just running a Terraform apply. And then we've actually got this wee run command. That's just, you can use this run key to essentially run anything you want. It just runs straightforward bash. So we have that running a bash script, which in sequence runs a couple of Python scripts. So what is the typical workflow for, like, what does this whole workflow look like whenever you're using it? So first of all, you open up a PR. As you can see, I'm just going through the process of adding a new S3 bucket to our staging cloud buckets directory. Then once the PR is opened in Atlantis begins to auto plan those changes. So Atlantis detects the changes from the git diff and is going to run all the project definitions defined for staging cloud buckets. And then here's the kind of YAML which dictates that. So you can see that the change was in the staging cloud buckets directory, and we have a project definition for that. So whenever it sees that there was a change to that directory, it's going to use the workflow, which is defined below, and it's going to use our Atlantis demo staging 1 workspace, and we've got auto plan enabled, so that's why it was able to trigger off straight away. And then you get like an output, your standard Terraform plan output to say what that change is going to do. Then we make sure that it can meet all of the conditions. So has this been approved, and are there no conflicts? So there's the piece of YAML that dictates those conditions. And then the deployment phase on this. So once everything meets the conditions and the criteria, you can type in Atlantis apply, or you can have Atlantis auto apply this in the same way it runs the auto plan. And then you submit that comment, and Atlantis will just give you your apply output and apply those changes. And then once that's all been approved and applied, you can just merge it in and delete your feature branch. So where does the shift left come from? So in Atlantis, we just have our DivvyCloud endpoint sitting outside of our infrastructure, and we just send off our plan file, and DivvyCloud scans that and gives us back any issues or problems and in a nice comment. So as you can see, that actually had a bit of a failure due to the fact that there was no encryption enabled on that S3 bucket. So I've got a bit of a demo here, and I've just got it pre-recorded, so I'll just talk over the top of it so you can see how that process looks whenever you're developing.
Can you make it a bit larger if it is small?
So I've just got this demo branch, and I'm going to add our new bucket, which is called another bucket, and I commit that to Git and open up a PR for the demo branch. Just push that up. And then open that PR. And there's our change, and then just create that pull request, and that sends off a request to our Atlantis load balancer with it using that GitHub webhook. and triggers our infrastructure as code scans and shows us our Terraform output as well. So as you can see, there's that failure for no encryption on the bucket, and we can see our plan output. I'm just going to add one bucket. So I need to go back and add some encryption to this bucket to get it to pass the infrastructure as code scans. And then the process just restarts, does another iteration. This time it comes back and doesn't give us any failures, and that's been fixed. And then we can see our output again. And then we can comment or wait for an approval. So we need to go and get this PR approved before we can comment Atlantis apply. So I'll just skip this on a wee bit, probably a second for it to. Let's just skip the whole. Can't even get the demo, pre-recorded demo to work right. It looks like it's just went the whole way from scratch. The loading bar is away down here. All right, okay. And I'll just let this run and wait for the approval to happen.
When DivvyCloud found the problem there, would that have allowed somebody to apply it? Was that DivvyCloud sort of feedback enforce change, or is it just, or sorry, enforce a set of standards, or does it?
I know what you mean. So we don't currently have if the DivvyCloud scans fail, we actually get a because where that DivvyCloud scan script is located, it's located in your Atlantis Yaml. Basically, you're defining that as a part of your plan phase. And if that scan fails, then the plan phase fails, and then the Atlantis planning phase won't allow you to plan out that definition because it never passed. So if those scans fail, you won't be able to run an Atlantis apply because it won't apply failed planning phases.
Okay, cool. Thank you.
So since this has now been approved and there's no merge conflicts, you just comment Atlantis apply. And Atlantis then kicks off and runs your Terraform apply based on that plan that it output above. And then you can just merge it in, confirm it, and delete the branch. So in conclusion, by enforcing this kind of workflow, we save a lot of time as it's only really planning and applying the changes. There's no need for Terraform installed locally on your workstation. In theory, it's nice, but so it means you don't need all your developers to have Terraform and struggle with Terraform versions and providers and plugins. Although it probably is still more efficient to run a Terraform plan locally before opening a PR, and just make sure everything's working. No more, it just worked on my machine. Atlantis, if the Atlantis cannot plan the change, then the code won't be merged. Then there's also reduces the risk of configuration drift. The shifting left helps catch any defects before they're deployed, making things a bit more secure. You've got that increased audit trail as well, so who changed what and when. And then we can also reduce the IAM permissions given to developers. So we can remove write access from all of our engineers and give them only read access to AWS. This will prevent manual changes being introduced through the AWS console or targeted Terraform applies or destroys locally on their machines. And but keep giving them the read access will still allow them to run Terraform plans and view any configurations in the AWS console. So where are we going next with our Atlantis workflows and development? So currently Atlantis, all the integrations are completely decentralized, and they're kind of bundled in to the project repo. Atlantis runs as part of that project's infrastructure, and it's just kind of segregated into its own Terraform workspace. So having this in such a decentralized way means it's kind of hard to maintain at scale, especially when you've got 133 Terraform projects. So we've kind of been thinking about what's the best way of centralizing all these Atlantis integrations into one AWS account. So, and what are the security implications with that? Work hasn't really begun on that yet, but it's definitely in the pipeline. I'm just going to finish off with any question and answers, and just a heads up, our team's hiring DevOps engineers. So if you find the contents of this talk interesting and would like to work on other automation projects with a variety of pretty cool tools and frameworks, our team is hiring. And if you want, you can look at the details on our careers page. I think the post's under DevOps engineers. And if you want to find me on LinkedIn or GitHub or send me an email, feel free. Even with any questions about this talk this evening, I'm more than happy to answer any questions.
Great, thank you very much, Dermot. That was great. Very interesting. This hopefully give people a few seconds to gather their thoughts and ask some questions. And while they're doing that, I have one lined up for you. You mentioned that Rabbit 7 have 7 production regions. Do you have code, or would there be a single PR change that would apply to more than one of those production regions? And how can Atlantis handle that, or is that why you've got 133 projects, because they're all specific? They're a certain set of components in a certain region?
Well, each project would normally be a not just one specific piece of infrastructure. It's normally like a full product or a full tool within the organization. So that's kind of our issue. In terms of deploying a whole region, we recently just deployed 2 new regions from scratch there just before Christmas for a lot of our projects. So there is times where we're deploying like 213 AWS resources. That was like one of our bigger projects, over a couple of hundred AWS resources in one Terraform apply. Obviously that doesn't work out as smoothly as you would imagine, but there are times we do run pretty large Terraform applies. And normally we just separate those by workspace and give each workspace its own Terraform variables file.
The way we're organized is, so we have a number of products that we sell to our customers on our platform, or application security, or it's a detection, or others that are not coming to mind. Automation of the bits of the security bits in between, so the teams can do more with less, you know. So, and a product or a project will live in its own, have its own Terraform repository, and that product or project will have likely a staging AWS account and a production AWS account, and that one Terraform repository manages infrastructure in both, including all regions, and we use workspaces to manage regions. So going from 5 to 7 regions is making things really hard for a lot of developers, because it's just more stuff to do. With Terraform, we manage mostly the stuff that, I'll say the stuff that doesn't change, but it's like the VPC and databases and IAM, security groups, SNS, SQS, all that kind of thing. We're like 95% AWS in Rapid7, and our team really only deals with AWS. So we roll out, our applications are done like auto-scaling groups or Kubernetes deployments and things. We'll use Spinnaker to deploy those. But the kind of the metadata is all done through Terraform. So it's like somebody wants to change an SNS topic or add an SNS topic. The hope here is that they can just commit once, and we have used Jenkins to deploy Terraform automatically, but it's cumbersome and it's not as smart. And one of the really nice things is they're showing, here's my, say, staging / buckets folder, or my staging / IAM folder. If you make a change in code to the staging / IAM, Atlantis will detect that you're only changing that and only run a plan for that. It will ignore the rest of any other state files or directories that haven't been impacted, because it's smarter than that. So anything we've done in the past tend to be a little bit blanket, like, okay, go and run a plan everywhere because that's safer. But it's so much noise comes from that, and there are teams in Rapid7 who have written like a homegrown version of part of what Atlantis does. You need to be a little bit more smart about what code is changing, but Atlantis has become a lot more mature, I think, and we try to not write too many tools these days, because I don't think that's really what we're here for. It doesn't, third-party stuff tends to be better, right? For most people, third-party stuff just works and lets us concentrate on the things that we should be doing. So one of our main goals as platform delivery is to help our developers go faster, and automating away as much as possible is a big part of that.
How do you feel about a PR being applied before it's merged? That doesn't sit comfortably with me, although I gather Atlantis does some locking around the PRs or around the state, so that you can have multiple PRs against a project, but they're not all vying for being applied at the same time. Is that right, Dermot?
Yeah, Atlantis has its own lock, which is different from the lock that you might set up with Terraform. So if two people were working on the same piece of Terraform code, and they both set off their PRs separately, it will pick one over the other, and it won't allow you to even run a plan on one of those PRs until the other one has been applied, or its plan file has been deleted and that Atlantis lock has been removed. So it prevents anybody from stepping on anyone else's toes.
Okay.
Do you give development teams ultimate ownership of what makes it into production, or do you have a kind of a boundary between engineering development and operations SRE, or whatever form that may take? And how are those boundaries enforced if you're relying on offloading your authorization to GitHub?
I would say I'll let Simon jump in after. I think this is kind of how it would operate is PD, our team, works alongside the developers, so if there's a bit of co-ownership there. Our Terraform repos are normally owned and used by the development teams, but if there's any large work that isn't maybe related to the operation of their applications, then that's when PD will come in and maybe do their networking or add in some infrastructure to help their overarching project. But whenever it comes to maybe project specific things like the code base or that's left to the development teams, but the actual resources like compute resources are kind of where that barrier starts to kind of get.
Oh no,
merged.
I mean specifically the process where, say I'm a developer, do I, maybe in collaboration with another developer, have the ability to push something to production without any engagement from any other part of the organization? Like, where do you kind of, do you have, like, does it have the concept of, you know, in terms of approvals before it'll allow you to actually apply in production? Does it have any understanding of the roles particular people have? Like, you know, does it require manager approval or, you know, operations approval or something, you know, to sort of push a service live, or is that freedom given to the engineering teams?
That freedom's given to the engineering teams. Normally, the kind of permissions and restrictions around the project are set at the GitHub teams level. So somebody from one team won't have access to certain repos, and other vice versa. Some teams actually have a lock on their files, so you can't actually merge in without there being like a top level admin on that repo, but that's set on a team by team basis. And I believe platform delivery, our team, are starting to kind of set the standard rules for who does what with the infrastructure deployments.
Yeah, we definitely have like a you build it, you own it sort of idea, like AWS kind of, you know, popularized. So devs are empowered to do whatever they need, and it's always been like that. And I suppose we find as we scale, that maybe gets hard, right? So a couple of things, like taking away my ability to do a Terraform apply as a developer, is maybe a good thing, right? Let the machines do it. For me personally, I know that I like to do an apply before I merge. That's because an apply tells you when you got, you know, I don't know if you can write Terraform perfect every time, you know, but it's just like you sometimes you need to apply to find that, you know, your syntax was correct, but it couldn't, you know, join the dots or work out its dependency graph or something, and you need to go back and think about that. But
yeah, no, I'm just thinking that there are some places where you have maybe compliance or regulatory requirements.
Yeah, well, we're moving more. We will move more into that area as we moved into different, you know, customer segments. That's going to become a thing. So one of the things this gives us is, you know, we have developers come here and they go, I can deploy straight to production. This is amazing. Or I can deploy to production. That's terrifying. Depends on, it's like a personal preference, and you know, we facilitate that, whether you want it or not. You expect people to take ownership of it, but
well, it's a good, like, it is a good thing, but it's like, don't get me wrong, I think it is a good thing.
Well, it's like you can deploy something very quickly, but then you're encouraged to do that because it demystifies it, right? Because it makes it's special, it's production, but it's also, it shouldn't be like a glass ceiling or anything. But you can also, if you do it regularly, then you know how to fix it, hopefully, right? So but with the things Dermot mentioned was, like, one of the kind of the nice side effects of this is developers do have a lot of access. They need access to do things, and if we take away their need to apply Terraform manually across, you know, all these regions, which is repetitive and boring and error prone, and it gets harder when you've got Kubernetes involved, because now you've got Terraform Workspace, which we use Terraform Workspace for everything. And if you have Kubernetes in there with a kubeconfig, and the kubeconfig must tie into the right Terraform Workspace, or else you can apply things in the wrong clusters and wrong regions, and all sorts of things can go on. Coding that, getting you know, Atlantis to do that will make that safer. We can sort of take back some of the permissions devs have. It allows us to meet other compliance targets as well for who can access what, who can do what. And you can, at the minute, there's nothing stopping a developer writing Terraform and applying it in production without it being merged. Not only that's doable. So it's not encouraged, but it's doable, and this will go some ways to prevent that. And it will cause other problems, right? Because people will go, I'm kind of, this is harder now, and my Terraform didn't work first time, and I've got to, maybe I left something locked, and I've got to go back and ask somebody to fix it. So we'll have to iron those out as they come, but it's definitely take us in the direction I think we need to go.
Is there any kind of, like, are there any concerns around Hashicorp's relationship with the project? I know they recruited the founder, he works for them, you know, kind of stepping on their toes a little bit on the enterprise side. Like, is there kind of is there a sense that there's enough momentum within the community to sort of have it exist outside of Terraform or outside of Hashicorp?
For Atlantis, I'm not aware of that, but I don't think we've any. We haven't talked about any concerns.
There's like Atlantis and Hashicorp are two separate entities, and the Atlantis project, the guy that started that project now got hired by Lyft in the States, and they're developing like an internal version of Atlantis as well, and it apparently has a lot of nice user requested features in it, and we're hoping that they get drip fed into the open source edition, and we can start maybe making use of those as well.
Yeah. No, I was like, the last time I looked at this was back in, like, say 2018, and sort of Luke had gotten hired by them, so I haven't seen it. I haven't looked at it since.
There's a couple other questions in the chat, Dermot and Simon, if you've got time. So there was a question there. Would you know if DivvyCloud under Atlantis support Azure and GCP? I know Atlantis supports Azure and GCP. Do you know anything more about DivvyCloud and what various platforms it supports?
I'm going to search that up right now. I don't know.
I know
it does. It supports both.
But all three?
Yeah.
Okay.
DivvyCloud doesn't, however, support any other infrastructure as code other than just Terraform. So I don't think they support CloudFormation or Ansible or SaltStack or any of those tools just yet. It's primarily just Terraform. So I would, if you are writing infrastructure as code in another language other than Terraform, I would look at that open source tool called Kix. It looks like a really, really good open source infrastructure as code scanner.
Okay. And the next one follows on. Is there any alternatives that may be close to DivvyCloud that you can recommend to play with? And I think your slide there had TFSec, Chekhov from the Bridgepoint crew. There you go. Indeni, I haven't heard that one. What's Indeni?
They're a company that make a product called CloudTrail. It's exactly the same as all these other static infrastructure as code scanners.
Okay, cool. So just on that, you can see there that those insights, they call them like you can define like the rules you want to, like your minimum kind of thresholds of what should pass for your infrastructure configuration, and we encrypt all our databases, all our RDSs are encrypted at rest. That's just been a standard for years. There was a time when an RDS has got to create in production without encryption, and to undo that is a lot of pain. So, so we can detect that in production and remedy it, but this does not necessarily. It doesn't take away the need to monitor production, right? So that's always there, but it hopefully catches more things, right? But and it kind of builds in the mentality that security from the get-go. So it's I suppose we see more and more of this kind of like multifaceted approach to security around. Like in a container world, it's okay, we build containers. What's your base image, and then do you assess a built container? And we have tools and products that do that and tell us, yeah, this container is fine. It doesn't contain any compromised or out of date packages. But that doesn't stop somebody from deploying like a compromised container into production, unless you're running some kind of like, what do you call the controller, the admission controller in production. So we're just finding that we're just adding more and more kind of levels of security, and they complement each other rather than replace each other.
Just on that complementary nature, we use OPA for an admission controller, and we also use it for enforcing policy in Terraform plans. So you can do pretty much, it's quite nice because you get, you have one tool, one language for sort of building and defining your rule sets and so on. It's quite interesting to look at.
Oh, how do you spell OPA? OP.
OPA, yeah.
Okay.
Like the expanse.
OPA and conf test are tools that I'd love to hear more about, John, if you're volunteering. I know you've already spoken for us before.
I spoke about OPA at B-Sides.
But, okay.
It's Gareth Rushgrove that wrote conf test.
Yes.
So I know him. Could probably tap him. He loves to talk about stuff. He could talk about AquaSec as well, which would be quite, or not AquaSec, Snake. He's like VP of product there, so yeah, an interesting person to get talking about it.
There's another question in the chat there from Graham. Do you deploy out application code along with your infrastructure, or separate it and use some other method?
We've got a bit of a hybrid model going on. So normally we separate things into separate workspaces. So we'd have a separate workspace for VPC, and then maybe applications, and maybe some other workspaces for other sections of the infrastructure. Maybe it's databases, might be a database workspace. So yeah, they're all nicely confined into their own kind of areas. But then we do have some monolithic directories, such as the cloud directory, where it's got everything from the VPC to the application infrastructure all loaded in and bundled into the one directory. And we're trying to move away from that kind of structure and move into a more separated workspace structure as well.
I think is that a question? I actually initially read that is, do we deploy applications with Terraform? But I think it means, is that the source code of the application, like in our case, it's mostly Java. So a Terraform repository would cover a single project, and that project might have, that really means a team, and that could be dozens of microservices. Each microservice would be defined in its own GitHub repo. It's and they're built, and we build typically war files or lambdas or containers, and we deploy mostly with Spinnaker. So Spinnaker is it's like an open source successor to Netflix's Asgard, which was very much an Amazon AMI based deployment tool or for deploying AMI based code. Spinnaker does it's kind of EC2 based or Kubernetes, or like a hybrid of the two. It does support other clouds, but we don't use it for that.
Simon, you mentioned about using Terraform to talk to Spinnaker. Is that one of the instances where you would have Terraform and Atlantis poking Spinnaker into action to deploy a new version of a piece of code, to deploy an artifact into production?
Maybe Mark, do you want to speak a little bit about how we more recently kind of moved to defining our Spinnaker pipelines with Terraform?
Sure. Yeah. So we just use Terraform really for I guess posting the actual pipeline code, like the Spinnaker pipeline code. The Spinnakers that just defines the pipeline that then will need to be manually triggered by a developer when they want to deploy a new version of the application. So we mainly talk from Terraform to Spinnaker for Kubernetes applications. So the pipelines that we post, they'll just be like a Helm chart, basically just saying Terraform, Spinnaker deploy this Helm chart. Yeah, that's really it.
Okay, thank you. All right. Well, once again, Dermot, thank you very much. It's very interesting, very useful. If you've any other questions, people, get them in now. If you've any ideas and suggestions for talks, please get in touch, either to something you'd like to hear or something you'd like to give. Please get in touch. John and I are always delighted to hear from more people. If nobody else has any questions, once again, thank you very much, Dermot. Thank you, Simon and Rapid7, and Mark as well, and anybody else from Rapid7 that's helped.
Cheers, thank you. Cheers, Dermot, for doing this.
No problem.